What's up, everybody? Welcome to my digital classroom. Some of you did math and you're good to this. You're ready. Miss Vigenratman's class, welcome. Welcome to my basement. This is my house, and everything's been reorganized. My drums are behind this wall here. Everything's been squished to the side so that we can make space for you and in our digital classroom. So welcome back. I know you guys missed me so much and all the work that I'm about to assign you, but don't worry, I'm back. If you are watching live, I want you to be active. I want you to hear you. I want to see you in the chat. If your name is not in the chat, if it's like Pretty Butterfly or something, then just please write like, oh, this is, and then say, hey, Mr. Staff, this is, so I know who you are when you're texting. Okay. A couple things about the chat. I understand that you guys want to be silly, you want to be goofy, and you haven't seen each other in a while, so I'll give you a couple minutes to do that. But eventually, it's going to get old, and I'm going to need you to calm down, kind of like being in a classroom. There's going to be a time for silliness and a time that you are going to be on task. So I'm just going to ask that in the chat room that you kind of figure things out, be silly, be goofy, but then calm down and start following along in the lesson. I'm going to ask you to type some things in the chat to respond to some questions. And so it's kind of hard to do that if people are still being goofy, all right? So I totally get it, though. You miss each other. You just want to hug each other, but you can't because of COVID, so don't do that, all right? We are going to get started, and all three classes are at a different spot right now, okay? And some of you missed some lessons. You missed some things. And so what I'm going to do is I'm going to kind of quickly recap and catch everybody up, okay? Maybe some of you are like, I don't want to rewatch this. Okay, well, maybe you want to skim through and make sure that you've caught everything up, okay? Or maybe while you're watching this, maybe take some time and update your what's those things called? Your notes that I can't find. Why can't I find them? Please hold. There we go, these. Okay, maybe you want to be working on these while I'm teaching. Okay, so we are on lesson 3, characteristics of fluids. Okay, and so we'll be covering things that you can do on this. Okay, so get out this slide and start taking some notes, especially my class. All right, you guys have not heard any of this. Okay, so we're looking at our lesson, characteristics of fluids. So remember, you need to be able to use appropriate technology, science technology vocabulary, both in how you speak. In the chat room, I'm looking for proper vocabulary. Okay, we're going to be, there's lots of this thing. Okay, looking at different things like volume, temperature, gas. Okay, especially going to be looking at flow rate today. Okay. What is flow rate? What do you think flow rate is? 2 words, you know both of them, but we squeeze them together. So pull them apart. And what is flow rate? In the chat, tell me what you think flow rate is in less than 5 words. Okay, go. Put it in the chat. That means this is the time for the chat to kind of calm down, stop being goofy, okay, and start being on task. Okay, so in the chat, tell me, what is flow rate? What does it mean? All right, and I'm gonna get some stuff. And we talked earlier about how fluids are anything that flow. Okay, hopefully you don't have to go to the bathroom. This might make you want to go. Okay? So flow rate is just like what it sounds like. Okay? How fast, at what rate is a fluid flowing? Okay? So here I have a beaker, and you're not going to be able to see it because it's clear, but it's 300 milliliters of water, okay? And just by using simple terms, we could say that this is me pouring it really slow, whereas this is me pouring it really fast, okay? So that's the flow rate. Flow rate is the measure of how quickly a fluid moves, okay? So let me move Let me move my video here. Okay, so flow rate has units, okay, and it's measured volume per unit of time, okay? So how much fluid is being moved in how much time, okay? So if you put a timer on for 10 seconds, I could go 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So I could measure how much fluid was moved in 10 seconds compared to 10, 9, 8, 7, okay, much faster. Okay, so there's a bit of math to this, not a lot, not hard, nothing like our last unit. Okay, and so you're gonna write this down. The flow rate is equal to how much fluid, the volume of fluid, divided by the length of time that it takes to flow. Okay, so write that down. Flow rate equals the volume of a fluid divided by the length of time for it to flow. Okay, or we could short form that to be FR, flow rate, equals V over T. Okay, so a little example here. I have a student named Juliet, and it takes 12 seconds to fill up her 1 liter bucket. What is the flow rate? Okay, so there's the question. That's a question I might ask you on a unit test. Okay, it takes Juliet 12 seconds to fill up her 1 liter bucket. What is the flow rate? Okay, first thing you always start with, okay, whether it's Miss Oikawa or me in math, is you always start with a formula. Okay, FR equals V over T, or flow rate equals volume over time. Okay, the second step, you're going to plug in the numbers that you know. Okay, so let's get the right thing. Here we have 12 seconds. Okay, seconds is the unit of time. So we can pop that in. Let me just turn that off because that's annoying. Okay, so we can pop that 12 into this T. Okay, and then the other one over here is 1 liter. So liter is a measure of volume. So how you say, Mr. STAV, how do I know where things go? Okay, you have to be able to know that seconds means time and liters means volume. Okay, and I'm pretty confident in your ability to do that at this point, and therefore I think the math is much easier so far than our last unit. Okay, so we plug that in, 1 liter over 12, okay, or 1 liter divided by 12 equals 0.08, okay? And just like we talked about in the last unit, units matter, okay? So for flow rate, it's always liters per, that slash means per, seconds, okay? So we have liters per second, okay? If you put 0.08 liters, you're not getting the answer right. You put 0.08 seconds, you are not getting the answer right. It is liters per second. Okay? Now, what makes a fluid flow faster? What makes it flow slower? We're going to look at that today. Okay? So in this GIF, I don't know how you would type that in the chat, but tell me which one it is, G or J. Is it with a J or a G? You tell me. Okay, you see this firefighter, obviously he's a rookie, and he is making a fool of himself, but he is being affected here by the rate of flow, the strength, the pressure of this hose. Okay, if I was to move maybe I can move down here for a bit. Okay, so you're gonna write this down. Flow rate is affected by what type of fluid, okay, is flowing. Okay, we're going to look at that deeper using an experiment. Okay, and 2 of the 3 classes got to do that in class already. So the thinner the fluid, the faster it'll flow. Okay, and this is something that is kind of natural. You've already known this throughout your whole life. okay? But now you're gonna actually see it in practicality. You're gonna learn the science behind it, okay? Okay. The flow rate is also affected by the force pushing on a fluid. Think about it. If you turn a tap on just a little bit, there's just a little bit of force pushing it out. Is it going to flow faster or slower? Okay, slower. And if you crank on the hose or the tap, like some of you, Dylan, do in our classroom, and the sink goes everywhere and makes a huge mess, and then you have to clean it up. Anyways, we'll move on. Dylan, Mayor. So the more force, the harder you turn the tap on, the faster water's going to come out. Things that you've known your entire life. Okay? The size of the opening. Okay? Looking over here at this GIF, or GIF. Okay? You've probably seen this hose before, right? You get this from the dollar store. You put this nozzle on the end of your hose, and as you turn it, right, you put it on jet, it's going to come really, really, really hard. Okay? You have a good flow rate. Okay? So the different size of the opening changes how fast water is going to flow. Okay? A fire hose has a much wider diameter. Okay? And so a garden hose won't have as much force or as much flow as a fire hose. Okay, with a bigger diameter. Actually had those over from math class. Andy. Okay, and then the last thing that we're going to talk about is that the type of surface that a fluid flows over. So if I was to pour water on the tile of our classroom, it would flow pretty fast compared to if I poured it onto like grass, it won't flow as fast. Okay, because the smoother the surface, the faster the flow. Okay. All of these things so far, nothing has blown your mind or surprised you or been any new learning. It's just been a way of summarizing things that you've known your whole life. Okay? But what I want to do is look at this one, the type of fluid. Okay? And we have a special word for that. And this is a very, very important word. You need to know this. You need to learn this. You need to memorize this. Okay? The word viscosity. You actually learned about this in grade 5. Okay, Mrs. No, we didn't. Yes, you did. You just forgot. You forget. Okay, so viscosity is all about talking about the thickness of a fluid. And then, in other words, a fluid's ability to flow. Okay, so the thickness, remember we said the thicker a fluid, let's see if I can do this. Here you see 3 test tubes. 1, 2, 3. We have the same marble in all 3. However, this one is already at the bottom. This one's going a little bit slower, and this one's going a lot slower. And what you're seeing is the marble's not changing. There's no magnets or anything. You're just looking at a different viscosity. This is a much thicker fluid than this. This is a very thin fluid. And this is like a medium thickness. Okay, and so you're seeing them float to the bottom at different speeds. Okay, so viscosity is a measure of how easily the fluid particles are able to slide past each other. Now, Mr. STAV, slow down. Whoa, hold on. Okay, I am going to go pretty fast because this video will be online YouTube forever. You can go back and you can re-watch this. You're going to go to mrstav.ca/science. You're going to find the characteristics of fluids lesson, and it's going to be pink. It's going to say live lesson. You're going to be able to watch it again and again. You're going to scroll back. Lucky duckies. Okay? So this brings us to our poll. Okay? So before we get to the poll, you are able to do question 2. Okay, we talked about flow rate. Okay, so you're able to do question 2. You're able to do question 3. And we'll get to question 1 and 4. Okay? Well, right now, let's skip over. Oh, and there's a second page. I always forget about the second page. We're not able to do any of these questions yet. Okay, time to skip to this page. Viscosity Variety. Okay, so we have 2 slides here that you need to be able to complete. All right, and so what we're going to do is we're going to take some of these items, okay? Because of COVID, I actually don't have all these items readily available at my house. So I do have ketchup, I have honey. I literally ran out of vinegar today at dinner. I know you don't believe it, but it's true. I brought molasses. Hopefully it's okay. And I do have water. Believe it or not, I have water. Okay. I'm not going to do the oil. Okay. And in the classroom, we also did, with the classes that did this, we did corn syrup, which is a lot like maple syrup. Okay. So I brought some of these, and we're going to do this experiment, this poem. Okay. All right. So you're probably you're very familiar with syrup, ketchup, honey. You're probably not familiar with molasses. Molasses is used for different things in cooking. One of my students told me that they feed it to their horses last year. They told me that. So there you go. Okay. Yeah, smells bad. Yeesh. Bet you wish you were here to smell that. So, what do you know about molasses? What you're going to have to do is make a prediction based on what you know. All I know about molasses is people say, you're slow as molasses. And you're like, no, I'm not. No, yes, you are. You're so slow. No, I'm not. Yes, you are. You're slow as molasses. So what I want you to do is go to your predictions, and I want you, in order, to write what you think the order of these fluids. Okay? Who's going to go the fastest? Who's going to go the slowest? Okay? If you did this before, don't blow it in the chat. Okay? If you have not done this, so basically, I think it's only my class who hasn't done this poem. Write in the chat what your prediction is. What do you think is going to go the fastest, and what do you think is going to go the slowest? Okay? So go ahead, take a couple seconds, and put that in the chat. Ready? Go. I'm going to use this time to pull up a video. Okay. Hopefully all your responses are in there. All right, here we go. I'm going to take some water. And you're going to, hopefully, be able to see this. Front row seats. So let's move it and make it the feature item. You know what I didn't do? I didn't add syrup on here. I'm going to add syrup. It's not in your notes, but it's kind of cool to see it. Because I can. Okay. So, random order. Let's go syrup first. Okay. Did you catch its speed of its flow, aka its flow rate? It's pretty good speed. Okay, you got that? Okay, make some observations, write them in. All right, let's do some honey. There it goes. Now, this is a proper experiment. What we would be doing is measuring out how much of the fluid we're putting on. But immediately already, you can see that the syrup just went right down when honey is just creeping along. In fact, I'm going to bring water into the equation here. And I'm going to put some water here. And you're going to watch the speed that water travels down here. Okay, it's actually because I'm using cardboard, it's just absorbing it. Okay. What do you want to do next? You want to do molasses or do you want to do honey? Let me know in the chat. What do you want first? Molasses? Honey. Molasses? Honey. This is not honey. This is ketchup. What am I doing? Molasses or ketchup? Molasses or ketchup? Okay. For those of you that are first time in the chat, this is actually a pre-recorded lesson. So you're actually going to find that I'm in the chat room live answering your questions and responding and queuing you guys because I recorded this last night. It's 10:46 if you can see on my bar. Okay? Let's do ketchup. There we go, Mr. Ketchup. Honey has kind of just almost stopped there. Go, ketchup. Maybe we gotta shake it a little. This is pretty new. We got it from Costco. Whoa. All right, I got some ketchup on there. There she goes. Go, Mr. Ketchup, go! 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 It's not going. It's not going. Honey's almost there. Great job, honey. Proud of you, buddy. All right. And let's get some molasses to see your predictions if they were right. Here comes molasses. There he goes. Can you believe this? It's beating the ketchup. Unbelievable. Unbelievable. This is huge. This is huge. Okay? Now, if you actually want to see a video from the classroom, you can go to mrstav.ca/science. Let's bring this over. Okay, and this is a student submitted time lapse. It's a little shaky, a little shaky. Okay, there's the molasses, there's the water, there's rubbing alcohol. Okay, if you're missing any of the experiments, you could always go to mrstav.ca/science and you can see the experiments there. Okay, so what we're looking at here are fluids with different viscosity. Okay, the syrup is kind of a pretty thin fluid, and so we see it flow pretty quickly. Okay, water is a very thin fluid, and it flows real quickly. Okay, faster than the syrup. Okay, what we probably should have done is done a race, put them on at the same time, and watch them race down. Okay, and molasses, molasses actually went at a pretty decent speed. I would say that molasses actually beat honey. Okay, you saw how long it took honey to make it to the bottom. You can rewatch this video and time it if you want. But I can tell you that molasses surprisingly actually beat out honey. Okay, and so that means that honey is a thicker fluid than molasses. Now, ketchup here is quite disappointing, and ketchup has yet to make even a crawl. So we can understand that that means that out of all these fluids, ketchup is the thickest. And so we say that it has the highest viscosity. Let me just get my screens going again. Oh wait, I need this one first. So what I want you to do is in your unit binder, I want you to go ahead and change these based on how, make it almost like a bar graph of how fast. So for example, we saw that ketchup barely moved. Okay, we saw that water was the fastest. Okay, so what I want you to do is use this to make like a bar graph to show the speed. They think of if you're writing a unit test and you go back to see the different viscosity, this will be like your cheat sheet here. Okay, I'm going to do edit undo so that it's not messed up for me in the future. Okay. Now, we're going to move on, and this is way faster than I would have done it in the classroom, but you have the ability to go back, pause it, and reflect. Okay. So, if viscosity is the thickness of the fluid or the ability to flow, we have two terms that are really important for you to understand today. Okay, viscosity is affected by these two words, cohesion and adhesion. Write that in your notes. Cohesion and adhesion. Okay, we're going to look at those in depth using the next PO. All right. So cohesion and adhesion are a little bit different. Cohesion is the attraction. Let me move my video screen here. Okay, cohesion is the attraction between the same. Okay, the same particles. Okay, and adhesion is an attraction between different particles. Okay, so keep these monsters in mind. So cohesion is the attraction between the blue and the blue. Okay, and adhesion is the blue monster and a red monster. Okay, this is kind of my visual way of showing this. This will make more and more sense as I move forward in this lesson. Okay, so cohesion is the force of attraction between the particles of a substance. Okay, fluids with higher cohesion, okay, will be more viscous and they will flow more slowly. Okay, now in the classroom, with the two classes that actually got this far, I had them standing on a tarp. And it was a small tarp, and I said, the class that gets the more students on their tarp wins. And I forget how much money I said, but I'm sure in the chat you will remind me that I didn't pay you yet. And I believe that Ms. Vidgen Ratnam's class are the champs right now, but I can't pay you until I have a chance to let Mr. STAV's class see if they can do it later or not. If not, I'll just pay you Ms. Vidgen Ratnam's class. Okay? I do have pictures of it, but I didn't think of this to pull it up for you. So the higher the cohesion, the more viscous or the more viscosity it will have. Okay, so think about this. The more that particles hold on to each other, the slower they go. And think about running. If nobody's holding on to you, you can run fast. But if someone is holding on to you and dragging you, you're going to move slower. So if you look at honey drips really slowly. Okay, and that means it has a high viscosity, and it means it has a high cohesion, that the particles of honey are holding on to the other particles of honey pretty tightly. And ketchup, incredibly tightly. Okay? So I got these GIFs. I really like the word GIF better than GIF. And you see honey flowing here. Okay? Now here's an important slide for you. Okay, pay attention for this unit test. Cohesion is responsible for a term we call surface tension. Okay, and surface tension is the attraction of water molecules, okay, at the top or at the surface of the water. Okay. I don't know if you've ever gone into a lake or a river and you've seen these bugs that stand on top of the water. These are called water striders. And it is pretty cool. They literally can stand on water, okay? Because they are able to stand on top of the cohesion and they don't break the cohesion. See, what happens is when we go into the water, we actually break that surface tension. We break that cohesion by our force and by our how heavy we are. Okay, but these striders, they actually sit so calmly and gently on top of these particles. They don't break the cohesion, so they're actually able to stride and move and swim on top and even jump. Yeah, that's a pretty crazy slide. So this is the actual footage of water striders. This is what they do. They hang out on top of water, on top of the surface tension. Okay, so this is cohesion. Okay, adhesion is not the same. So that was like water to water. Okay, fluids with higher adhesion will stick more to a container or a pipe. So this is something I could never do in class, is pull out peanut butter. Okay, this is my cheap no-name bread because times are tough. Okay, when you open up and you look, all that peanut butter that is stuck to the surface or to the sides, okay, that is adhesion. And you know that word adhesion, right? You know that in terms of like adhesive tape, right? You use tape to adhere something to another thing. Okay, so this is adhesion. I also brought some salsa with me. Okay, and you see that residue. Okay, that's the salsa adhering. Okay, you'll notice it's nothing like the peanut butter, and that's because it has a lower adhesion than peanut butter. It does have some adhesion, okay, but nowhere near the extremes of peanut butter. Okay, I've never been able to do that in class because peanut butter would be a very bad idea in class. Okay, now when a fluid flows through a pipe or a container, it can actually, adhesion can slow their flow rate as they get stuck, as they adhere just a little tiny bit, that friction to the side of the pipe. Okay, and so adhesion can actually slow the flow rate. Oh yeah, we just talked about. Ooh, hot chocolate. I literally just finished a hot chocolate, and look at the adhesion. Ew, that is going to be a pain in the butt to clean. I have to probably let that soak overnight. The adhesion is intense. Look at that. Nothing's coming out. I'm pouring it over a MacBook. You should never do that. Okay? But interestingly enough, if you were to go, I don't know if your parents have the hose on yet, okay? But if you were to turn your hose on and you actually put your hand in front of the hose, you'll notice that the water in the center that's not touching the edges, the perimeter, okay, that's actually going to be flowing faster than the water that's coming out from the sides of this tube, of this hose. Okay, interesting fact. Okay. So to look at cohesion and adhesion, we started a poll, and we spent a lot of time in the class because we were just having fun with it. And so obviously we won't get to spend as much time. But you could totally do this. I don't know if you have an eyedropper in your house. Okay, you can use any eyedropper. It'll look different than the ones we have in science. Okay, and you need a quarter. And if Meher or Dylan or Aaron are in the chat, would you shout out and holler? They are the world record holders for this poll. Don't say anything yet of a number. But what I want my class to do is go ahead and make a prediction on how many drops of water. You go this way. There's 1 drop of water. 2, 3, 4, 5. Okay. I want you to make a prediction on how many drops of water we can actually hold on this coin, on this quarter. Okay. Make that prediction. Okay. Now, we would have done this in class, and if I felt comfortable that everybody knew where an eyedropper was in their house, I'd maybe even pause, but I wouldn't know where an eyedropper would be in my house if I didn't grab these from the science lab. Okay? So, man, this molasses stinks bad. Yeesh. So we then went ahead and we dropped water on the coin. 2, 3, 4, 5, 6, 7, 8, 9. Now in class, we actually we counted and we did a pretty good job. And so I'm going to move a video here for you. Okay. There we go. Let's start from the beginning. Okay, so here you can see them adding water droplets. More. Okay. Now, what I want you to notice is this. Oh boy, that was really bad. And they won't let me erase it? Oh, it's getting worse. Okay, well, they're not letting me erase it. But I want you to notice how the coin actually is bubbling over. The water is bubbling. Okay? And this is an example of cohesion. Okay? So in class, I mentioned earlier that, man. So I actually had our students stand on a tarp. And the idea was that there was not enough space for a lot of students. I think the winning number was 15. And so Mr. McKinnon's class got 14 kids on the tarp. Mr. Vision class got 15 kids on this small little tarp. And the key was that they actually had to lean back and hold on to someone from the opposite end. And they were showing cohesion to another and holding each other on. Well, here we're seeing the surface tension and this cohesion holding this bubble of water above the perimeter of this coin. It's a pretty insane, cool little trick that we can do in grade 8 science. So go ahead in the chat, Aaron. Dylan was a beast. Dylan literally, I don't think he blinked for 20 minutes as he dropped droplet after droplet after droplet. And on a quarter, I think he got over 400. It was like 450 or 430 or something around that. He'll probably be yelling it in the chat. Beast mode. I have never seen that. Last year's world record was like 130. But I have to give a special shout out to Ebony, who I think she was at like 350 before hers cracked too. So she would have had an insane number, but Dylan is crazy. He's insane. So I don't know if that will ever be beat, Dylan. So congratulations. So yeah, let me go back to my PowerPoint here. Okay, here's a good look. I think I took this in class. Okay. Look at that bubble. Look at that surface tension. Look at the cohesion that's happening on top of these coins. Okay. So cool to look at. Okay. So viscosity can be affected by a fluid's ability to adhere or be cohesive to itself. Okay. Let me just get some stuff going here. Please hold. Now, the next PO that we're going to look at is called Wonderful Water. Okay, so this is the first part of the Wonderful Water, was water dropped on a coin. How many droplets did you predict? How many did we actually see? Okay, the next one we're going to do is the paperclip placed on water. What do you think is going to happen when I place this paperclip into water? Go ahead and make your prediction. Oh no. Where did my video go? He's back. I'm gone again. Why did it do that? Okay. So what do you predict is going to happen when I place this paperclip in water? Ready? 3, 2, 1. Could it have sunk any faster? I don't think so. But now, please hold. I'm going to focus and I'm going to use magic. And I'm going to summon my magic skills. And this is something that you can do at home. What the heck? How is that possible? I have a paperclip floating on water. Now, you literally just saw me place a paperclip in the water and it sunk. Now this would be something that you might want to pause the video, go to your kitchen, grab some paper clips and grab a cup of water. You don't need a beaker. Just grab a cup of water and try to float a paperclip in water. Little tip here is you need 2 paper clips to do this. How is it done? How is it done? How do you make a paperclip float on top of water? I'm sure by now people have ruined it in the chat. Okay? So the key is, actually shout out to Amarian. He's the only student I've ever had that was able to do this with 1 paperclip. He was successful. The key is that you have your normal paperclip and then you take it and you bend it. Into an L. Okay? And you hold the other paperclip like this. Okay? Now, what this allows me to do is slowly lower it into the water. And then it sits on top and I pull that L away. And why that works is that concept of cohesion and surface tension. Okay, we're mimicking the lightness of a water strider, those bugs that I showed you on top of the water. Okay, these bugs literally don't break by their gentleness and how light they are. A paperclip is light enough to not break the surface tension. Okay, but we have to lower it in such a way that we're not breaking the surface tension. So we lower it slowly down like this. So it just touches and floats on top of the surface tension. Boom. Make your observations. Do it. Go. Okay. The last one is the graduated cylinder. Okay. To look at adhesion, at how in a pipe, water actually will adhere to the sides of a pipe. Okay? So we're going to move this to the side without getting my desk nasty. So to do that, we're going to fill a graduated cylinder or a test tube with water. This will be very hard for you to see, I think. I've never done it via live teaching, so online. Okay, so going back to my PowerPoint, looking at surface tension. Is it possible to make a paperclip float or sink? Will it float or sink? Make your prediction. Okay, and then there's my explanation. Fix it on. Okay, there's a video. You don't need to see it because you saw it live in person. Okay, so we're going to look at adhesion. We're going to fill this graduated cylinder or this test tube, okay, up with water. Okay, and what I want you to observe is this. Okay, technically you would think that we're filling it and it's going to be a flat line across. Okay, but notice what actually is going to happen. Okay, so you see how it's like a bit of a circle? Okay, this is called a meniscus. See if you can see it. Not really. Kind of. Let's make my camera window bigger. Try again. Now this obviously would be best on a countertop and not moving it. So you can kind of see that it's curving up. And the reason it curves up is the concept of adhesion. Water is adhering to the side of this test tube. Boom, right there. Booyaka shot. Okay, get a little bit of adhesion happening here. And so this is going to be tricky in grade 9 as you do have to do measurements and displacement and stuff. You're going to need to understand that that meniscus is going to mess up some of your readings. So we always read from the bottom of the meniscus right here. So see up here, it looks like you could say that that was the measurement. Okay, but we always make our measurements based on the bottom of the meniscus. But that's for grade 9, don't worry about that. Okay. Okay, so this brings us to all the classes, okay? All the classes are at the same spot now, okay? So you have the ability now to answer all of these questions. Using what we just taught, you can answer, explain why flow rate is affected by viscosity, cohesion, and adhesion. You can calculate flow rate using the math, okay? You can give me some examples of viscosity, cohesion, and adhesion. You're going to rank them from most to least, okay? Look, the water striders are here. Explain that. Center of pipes, you can explain that. Okay, this one, look, just going to move this. If you think it increases, and if you think it decreases, then you're going to move those like that. Okay. You should be able to complete all of this PO, complete this slide, and you should be able to complete all of Wonderful Water. Everybody should be done that. So the next time I come live, I can confidently say that all 3 classes will need that lesson. Okay, we're going to start with a PO. We're going to look at temperature. How does temperature affect rate of flow? Okay, and then we're going to talk about density. Coolio, and we have another PO. Lots of POs. Remember I told you that this unit has lots and lots and lots of POs. Okay, so lots for you to learn, lots for you to observe, lots for you to explore. Okay, I highly recommend trying some of these. Try that paperclip. Even though you know the answer, see if you can do it. See if you can. Okay, so with that, we are scheduled to go live again on Friday. Okay, and then have our guided science groups on Friday. Okay, that is Good Friday. So I'll be sending out a remind text of what I'm going to do if I'm going to just post a lesson, and you can watch it on your own time. And if our guided groups will go ahead, or if I'll bump those to next Monday. Okay, so stay tuned and remind. I got to talk to Kirby, see what she wants to do, and get some feedback from some of your parents on what they would like. Okay. Thanks for joining us. Thanks for being in the chat. If you have questions, you can message me. The point of this is not to stress you out. We do not want you stressed. Okay? The point is to get you the curriculum, get it into you before you go to high school. Okay? I'm here to help you. I'm here to answer your questions. Okay? To sign up for a guided group. Okay, you don't need to see me that much anymore. You're going to type in bit.ly/STAV online guided. Okay, you're going to type your name in any of these spots. Okay, and when it's time for you to do your guided, these pink. So you'll see here, I put a link here for the video chat. Okay, you'll notice these ones aren't here yet because it's not Tuesday yet. Okay, so when you come to this page, you find that link, you click on it. Okay, Mr. Zapp, what if I don't want to use video chat? My parents don't want me video chatting. That's fine. You can be in the chat without your camera on. Okay, but what I'll be doing is I'll be kind of walking through some of the slides, and I'll be answering. If you have questions, Mr. Zapp, how do I answer this? Help me explain this post. Okay, so I'll be walking through that. Right now, you'll see I only have one person signed up for this 2 o'clock slot. Okay, so I would actually not run that because by law, we're not to be alone with a student, whether it be in a classroom or in a digital classroom. Okay, so I would just message the student and say, I'm going to bump you to the 2:30 slot unless you can get some friends to sign up. Okay, so I'll let you know if we're going to go ahead with that. So if you're not on Remind, you need to go to mrstav.ca/text. And you do need to be on Remind. If never before, you definitely need to now. Okay? So you need to go to mrstav.ca/text. Okay? This video link will be posted right here. Characteristics of fluids, and it will be pink, and it will say live lesson. Okay, and you can watch it over and over again. Here you can see the viscosity variety that we ran, and don't watch this one yet because that would ruin the fun of next lesson. Okay, so thumbs up. Thanks for joining us. If you have questions, write them down in your lesson notes and then come to Guided, and I will help you. Okay, we had an awesome time at Guided Math today. It was very helpful, I think. And it wasn't chaotic or anything. All right. So see you guys. Stay safe, stay inside, stay home, and be physically active. All right. Peace out.